Greetings and welcome once again to my new calculus channel. My name is John Gabriel. I often get a lot of recommendations in my academia uh, message box from academics who basically publish a lot of garbage, and sometimes I respond. So here's one by Radhika Miskita. So she wrote her dissertation on fractions and how in her study students had problems with equivalent fractions. Well, actually, equivalent fractions are quite simple if taught the right way, okay? So we don't actually have to even have numbers. We could, for all intents and purposes, remove these numbers on the line segments, but I put them there so that you can see why fractions are equivalent, okay? So we'll let one side of a triangle be the numerator and the other side be the denominator. And we can extend this or decrease it. Doesn't matter how we do that, okay? Any way we like. And what this shows you is that 2 is to 4 as 1.5 is to 3, right? So as long as you keep on, if you place a line there between the numerator and the denominator and you draw any parallel line to it, then any of these will be equivalent fractions. In fact, you could even add up these two sides and they'll still be equivalent. So for example, 3.5 to 7 is also a half, isn't it? So 3.5 to 7 will also be a half. Let's go there. See that? And all I've done is just taken 3.5 to 7, right? Now, that's all there is to equivalent fractions. And this here is available from Euclid's Elements, Book 5, Proposition 12, from which all the four basic operations of arithmetic are derived systematically and validly. There would be no problems understanding fractions, no confusions, nothing whatsoever. And by the way, this doesn't have to be a perpendicular angle. It could be any angle, okay? Doesn't matter. Any angle will do. All right? So we can change that as we like, and you can test these, and you'll see that these two fractions are, in fact, equivalent. They have the same measure, okay? They have the same measure. Now, whilst these ratios of line segments, in other words, the red line segment, let's just put this back here so I can get some scaling. This red line segment has a ratio to the blue line segment. Okay, so let's just do that quickly so you can get an idea. So if we say red line segment to the blue line segment, like that, okay, slightly longer, this is a ratio. And if we take the measure of this ratio, it's 3/4. Why? Because there is a line segment that fits into here exactly 4 times and into here exactly 3 times. This is what the ancient Greeks called pilikotita, or quotientness. Okay, quotientness. Now, the reason there is so much confusion with fractions in the operations is that the morons of the last 400 years have moved away from the true foundations of mathematics. In other words, the light and beauty of Greek mathematics, which is 100% sound. Okay, and similarly, this 1.5 is the ratio of this line segment to that one, okay? And again, there is a line segment here, okay, that will result in this. So if this is 2, then this is 1.5, okay? You actually count what measures them. So 2 of these and 1.5 of these. All right. Now, that's all it is, really. And I would strongly advise you to buy my free book. Okay. Very important book. Very important book. This book called The Ultimate Book of Numbers. I'll place a link to it. And also the importance of learning the right way. So this is an ongoing project, by the way. I share this only with the members. So if you became a members only, you'd pay €5 a month and you'd have access to all my research and the updates. Okay, so what I'm doing here is really just putting down on paper what I've had in my head for the last few decades, right? And that's a lot. Now, it's only $9.99, depending on where you buy it from. Very cheap book, and it's also features my theory of learning, which is CATIS. Very advanced concepts in this edition. So, and it's constantly updated. If you're not already a member of my channel, I would recommend that you join by clicking on the join button, okay, of any of my videos. So just go to any of the videos, click on that, go to the video, and press join, and then sign up. And of course, if you're not already a subscriber, become one to my channel, click like, and every now and again I'll share some gems with you, just like I've done here with the topic of equivalent fractions. I'm John Gabriel, and this is New Calculus Channel. Till next time.